Hello guys, this is Daniel and today we are going to continue our series blockchain programming for Vypers. Today we are going to continue coding in Vyper the guess the number game that we started in the previous video. And in the previous video we created a contract that can support being a game itself, but that's not very sustainable for the long term if we want that contract to actually be the core of a app. And in the next videos in the series, because this is gonna take a while, we are going to continue exploring how we can make this guess the number game be more sustainable to be the core of a app. And this is the first part today, and what we're going to do today is go over the requirements and introduce two new data structures in Vyper that are going to be key for developing this functionality. So the requirements for this are as follows. This contract should support multiple guess the number games. The creator of the game should risk 10 ETH to start a new game. A secret number should be established during game creation. And the secret number should be 0 to 100. The game creator cannot play in the games that he created, and each guess of the number in a game will cost 1 ETH. Each game should allow only 10 guesses. Once the 10th guess is made, the contract will expire and the funds will go to the game creator. Whoever makes the right guess will win the balance of the game. Once the right guess is made, a game should not allow people to play, and whenever a game it's either expired because the right guess was sent or because more than 10 guesses were made without one of them being right, then 1% of the funds that are transmitted are going to go to the creator of the contract, which is ourselves, the owner of the contract. So that's the way that we can make some money. But for implementing this functionality, we need to be able to support multiple games. And if you look at these requirements closely, you can see that what is happening there is that we need the game to actually be a data structure. And for that, we're going to introduce a new data structure in Vyper that is called struct. So a struct is similar to an object of or a class in object-oriented programming. It has several attributes. So we're going to define the struct game, and this struct game is going to have the following attributes. It's going to have a game owner, which is going to have an address as the type. Then it's going to have a secret number, a uint 256 type. Then it's going to have a game balance, which also is going to be a uint 256 type, and it's going to have a guess count, which also is a uint 256 type. Now we also need to know if the game is active or not, so we're going to create an isActive attribute that is going to be a boolean, and that's all the attributes of the contract. Now we also need to be able to retrieve those games and put them in some structure, right? Usually you do that with list, but in this case, because Vyper support for list is not the best compared to Solidity, we're going to do it with a hash map. And a hash map is a set of key value pairs where you have the key and you retrieve the value, and the value could be a struct. So what we're going to do is that we are going to have a game ID, and that game ID is going to allow us to retrieve information about a given game. So let's get going right now. So as we mentioned, we need a core ID to keep the IDs of the games that are being created. So we're going to call that one as a uint 256. And we're going to have a hash map. So we're going to have this game index, and this hash map is going to be defined in the following way. We're going to have hash map, and is going to have a uint 256 map to a game, which is the type defined here by the struct. So that's it for keeping the games, but we also need to identify the contract owner, because at some point we need to send payments to this guy to his Ethereum address. And that contract owner is the one that we're defining up there. So that's all the variables we need. Now we need to know how to go over adding games in a way that we leverage this struct that we created. But for that, first we need to create a constructor for the contract. So we're going to define something very simple here, something external. Doesn't need to be payable at this moment because to deploy this contract is not going to cost anything more than the gas. And we're going to define it in init. And this init, it's going to take no parameters and is not going to return anything. It's just going to serve to store the self-contract owner variable here as the message sender of the deployment, and that will make us the owner. And then we're going to keep the self-core ID equals 0, and that's pretty much it. We are going to be able to do this as the constructor. Now we need to be able to add games, right, and learn how to use these data structures that we are creating. So what we're going to do is something very similar to what we did in the constructor when the contract itself was the game, but we are going to leverage these structs that we have here and the hash map. So for that, we're going to have a function here that's going to be external. We are going to make it payable. And this function is going to be called def create game. And this create game, it's going to have a secret number that is going to be a uint 256. And we are going to return at this moment that we call this creator game creation function. We're going to return a uint 256 to try to return the index of the game that we created. Now we need some assertions here, so we're going to do that one pretty fast. We have to assert that the message value of whoever is creating this game is equal to 10 times 10 to the 18, which 10 to the 18 way is 1 ether, times 10, that's 10 ether. That's the price of deploying a game, and that is the initial price that we are going to have in the game. So we are going to send a message: you should pay 10 ether to create game if this assertion doesn't hold. And then we're going to have another assertion here that we're going to call assert a secret number greater or equal than 0, and secret number lesser or equal than 100. If this doesn't match with whatever is the conditions when the function is called, we're going to send the secret number should be within 0, 100. So that's all regarding the assertions. Now what we are going to do is something very similar to what we did when we created the previous contract in our constructor at that moment. So we're going to just initialize all the variables or the attributes of that game that we are creating. Self game index self core ID, because we are going to work with the current ID that we have, and at the beginning this is going to be 0. We're going to start our games with an index of 0. Game owner, it's going to be equal to the message sender, and that's how we're going to identify who is the owner of the game, because when there are 10 wrong guesses, he is going to get the balance. Now we also need to initialize, and let's just do a copy paste here. We need to initialize the balances, so let's do self game index self core ID, and we're going to do game balance. Okay. It's equal to itself, just for convention, and for readability we're going to have this one here, plus message value and that will start the balance. Then we also need to have the secret number, and the secret number should be equal to the secret number that is being submitted, so we just keep it like this. Then after initializing the secret number, we are going to initialize the guest count, and that guest count is going to be equal to 0. And then we are going to initialize whatever is the status of the contract at this moment. We are going to just call it is active, and this is going to be equal to true because booleans are initialized to false. And later on, when we work in the logic, we will know that we need this one to be true. Now we need to do some housekeeping, which is increasing the core ID variable. So that's going to be self core ID is equal to self core ID plus 1, and the return is going to be self core ID but minus 1 because should be the previous one because before we made the addition, because it's the one that we created. So let's save, and right now we are going to add a new function just to be able to see the balances. And let's do it again. So we're going to add an external function, and this function is going to be only view, and this function is going to be called def get game balance, and it's going to take a game ID, and this function is going to return a uint because it's going to return the balance. It's going to return a uint 256. Now we just need to return the value, so we're going to do return self game index game ID, which is what we are sending right now, and we are going to retrieve the game balance. So we save, and let's do another compilation. Right now that we have that function, there is something not going well there, and this is because we didn't add any type to this one, so it's uint 256. Save, let's clear our screen, we call it again, and it compiled just fine. And now we have to do the deployment, so we're going to deploy from the account 0. Now we're going to create games again, so we're going to do the create game from account 1, and we are going to create it with this value of 77, and we are reference that one with the index of the deployment first. So this is the contract object, this is the index of the deployment, then we're calling this function create game, and with a secret number of 77 from the account 1 of our ganache. Let's do it. So we create one game, then let's create another game, and this is going to be from the account 2 of our ganache, and the secret number is going to be 76, though that doesn't really matter. Now we are going to get the balance, so we're going to do a get balance call here. So we are going to call from the same deployment get game balance, and we are going to submit the game ID 0, which is the first one that we created, and it's going to return that the balance is 10th, and we are going to do game 1, and it's going to return that the balance is 10th. And if we do game 2, which would be a third game, is 0 because that game doesn't exist, it's not created. So that's the way that we work with the structs and hash maps, guys. This is very important to actually deploy and develop any dApp. This is knowledge that you need to have if you're going to develop smart contracts. So hope that you understood everything. If not, feel welcome to leave some comments in the YouTube channel. Smash that like and subscribe to the Morales channel. We are going to follow with this contract in following up videos.